We will now move to our next topic given by Bojan Sovilj, the first walker at Cloudwalker and a data geek with vast experience in implementation of analytic and big data technologies for business decision making. Bojan will give us an introduction to Amazon Redshift, a fast petabyte scale data warehouse that makes it simple and cost effective to analyze all the data across your warehouse and data lake. I would remind the audience to please post your question through our platform. And Bojan, the floor is yours.
Thank you. Well, first, let me ask you one question. Does anyone have a Redshift cluster running in production? Yeah. Anyone bigger than 10 nodes? This will be introductory. So my idea here is just to show you some queries and directly how to make a cluster. I think people usually today think about cloud that it is something, how to say, much advanced. I think that cloud is sort of abstraction and you can be more faster, much proficient, etc., etc. So I'm coming from Cloudwalker. Cloudwalker is established 2015, but as our sales guys say, we have around 100 years of experience in databases. So that sounds so interesting. Well, I think that you see this, but this is main reason why you should consider cloud to run your services on cloud. And you see here you have time, and on x-axis you have time, on y you have your infrastructure costs. So probably you are a good company and your costs will go higher as times go. So this red line is actually old-fashioned enterprise. So whenever you need computing resources, you go to procurement, and then you buy resources, and then you add those resources, scale your load, and then again, in 1-2 years or no matter, you have again demand for more resources, so you again buy more servers, and that is not like natural. So every business has kind of yearly downscales, so not every business is, you don't have loads, same loads through year. So this white curve is actually more natural resource demand. So what is the problem here? Here in this green, you have overscaled your resources, you are paying for something you don't actually use. And second problem is when you have much higher demand for resources and you cannot scale, so you are losing money in two ways. And that's what we say, why we say cloud is more elastic. We say cloud is elastic. This white curve is actually what cloud can give you. So actually you can go more naturally as your demand grows. This is actually why cloud, and there are also many other reasons, but I think this is the most good example, best example for why do you need cloud. And this is what Amazon claims about Redshift. So, I don't know, can you read this? Is there? No? Then I will. So Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost-effective to analyze all your data across your data warehouse and data lake. Redshift delivers 10 times faster performance than other data warehouses by using machine learning, massively parallel query execution, and columnar storage on high-performance disk. You can set up and deploy a new data warehouse in minutes and run queries across petabytes of data in your Redshift data warehouse and exabytes of data in your data lake built on Amazon S3. You can start small for just $0.25 per hour and scale it to $250 per terabyte per year, and this is actually true. So I think most important things here are two things, actually, that this data warehouse is columnar. So on the left side, you have a table. On the left side, you have classical transactional approach. and on right you have columnar approach. So basically, in this transactional approach, data is written off disks on disk row by row, and on the columnar, data is written column by column. So every select will work much better in this columnar approach because you are reading only columns for your disk, from your disk. Also, we should say that this approach has problems with inserting data, so transactional databases are very good for inserting data, while columnar are very slow, so you must insert your data in bulk loads. And second is using a massively parallel process. So actually, Redshift Cluster consists of leader node and other nodes that actually keep your data and run query. So basically, every node, the number of processors actually determines number of slices for your data. So Redshift will try to optimize search using those slices, using this parallel approach. So this is usual. This is our architectural model. We mainly do for gambling sector, and usual approach is this. So we connect to on-premise data stores and then use virtual machines, EC2 instances, to put data to S3. For me, no better technology for data lake as S3. So this is simple storage server, as Amazon called it. So you can put all your data there. You can use Amazon Athena to pose SQL queries directly on your CSV files. And what we actually do is take all those data from S3 and put them to Amazon Redshift. And then, based on that architecture, our clients can have reports, can have ad hoc requests, and can have, you know, more advanced predictive methods. What is important here also to stress is that, you know, these on-premise data stores, we usually see much adoption of Kafka, and essentially we work in, I see that Kafka is becoming standard in productional systems. So this is simplified data warehouse model. And now I want to show you what we managed to achieve with Redshift. And that is our product. It's called Smart Bookie. So as I told you, we work for very big betting companies, and they have very low analytical granularity. So I don't know who bets. Does anybody bet here? Like to bet? So 2 guys. That's not true. But okay. Actually, those guys, okay, let's put it another way. Yesterday, you have a Red Star Napoli match. So you have, for example, 400 different selections you can bet on. You can bet on whether Red Star will win, whether there will be 2 or more goals, whether both teams will score a goal. So I don't know, 400 to 500, maybe even more selections you can bet on. So every day, those companies have several hundred matches in their offer. Also, you can play live while matches, you know, you can play in 25 minutes of match, you can play on that match. So what are they interested in? So they are interested in aggregated information about where they lose money. So we use, now you will see, also very simplified, and for the purpose of this presentation, you will see how it looks like. So this is Smart Bookie. And now you will see this stream up visualization. We took Power BI because Power BI has that perfect stream up visualization which you can drill. And now I will show you how you can drill it and assess information about data. So this is sample of data, you know, not true. the size of this rectangle is money in, and the color is if there is a problem. So I see their gray line, rugby is a problem. But you know, they know that rugby is a problem. I have 2 years of data, so I can maybe select 2017, and I will have 2017. I maybe select, you know, smaller period for 2017, and I have it. So, but what else they can do? I will select 2018. I see rugby is a problem, so you see, I can even see basic metrics. So I can turn on drill in and then select this rugby. Something is happening, something strange is happening here. I cannot drill. Well, let me just select. That's because I don't have my internet connection. And I will need it. Sorry about this. Može. So I'll go, I have a hotspot. Sam bil problem. Ne, evo ti ovaj. Čekaj. So this is 2018. Imam. So when I click on rugby and turn on drilling, you will see performance of this rugby per leagues. And when I click on league, I see performance of this rugby per selections. So they see where they lose money, you know, so they then can, accordingly to that, do something with their productional models. So if you have 30 sports and let's say 100 selections per sport, you have 30,000 essentially logistic regression models they are using to offer their odds. So that's it. Now everything on that is on Amazon Redshift, and now I will open a console. And this is AWS Console, so everything very simple, you know. I can go to Amazon Redshift, select Amazon Redshift. So now I see clusters. If someone was to ask me 20 years ago, how would you like to see your database that is Amazon Redshift today is how I would like to see database. So now you will see what I can do here. I can quick launch a cluster. I can say how many nodes I need. I can select, oh, this is now a problem. But if I select, let's say, number of 4 nodes and click here, launch cluster, I will have a cluster in 10 minutes. Actually, on this year, data science, we managed to deploy a very large cluster it has 96 cores, it has 7.5 gigs of RAM, it has 750 gigs of RAM, it has 7.5 terabytes of disks in 20 minutes. So we managed to insert 1.5 billion of rows in 10 minutes. So I will go back again for a cluster. Now when I click for a on a cluster, I can see what actually I have here. I can modify a cluster, I can resize a cluster, I can even delete a cluster. Also very important is backup. So every data warehouse, whoever has data warehouse know what is a problem with backup and restore of a backup. So in AWS case, backup is run 3 times daily automatically. So I can select my backup and then, try to make my AWS cluster working from this backup. So what else? So this is cluster performance. So of course nobody do anything here because we are all day here. So when I select, you see, I'm so sorry that this is blurred, but actually, let me explain to you. So on this first graph, you see every query that was posed on database with time of execution. So if I go here, I see what query was posed to database. When I click on query, I see all the resources query used. So I actually see utilization of processor, I see network received through output, I see network transmit through output of all my nodes, leader node and all other nodes. I can, even here, I can see this is a full table scan, so I don't have like explanation of my algorithm. Let's find algorithm here. I will also select 1 week, and then in 1 week I see that 13 I have like 7,080 seconds lost on write. When I click here, I actually should see all the queries that have very, very, very big load. So, how hard is to connect to cluster? It's piece of cake. If I go here, again to Amazon, then to Redshift, then to clusters, I have, this JDBC or ODBC host URLs. Whatever tool I will use that host name. I will point to 5439 port, and then I can start query it immediately. So here I will show you, my idea was to show you this table. This is Redshift Cluster, and I will just show you how many data we have in it, in biggest table. So we actually need, this is 3-node cluster utilizing 3 DC1 large machines, which actually has two cores, 1 and 150 gigs of disk and 15 gigs of RAM. So I will run select. So you can see, or you cannot see 1 billion and 100 million rows that were inserted in 51 minutes. So when we are speaking about 1 billion of rows, do anyone here have like load of 1 billion? Yeah, great. I know how hard your life is. Yes. So actually our biggest cluster have 155 billion rows. So if we are speaking about 1 billion of rows, that is in Serbia case almost 4 years of all credit card transaction in Serbia. 4 years in 51 minutes. So I will show you how much storage do we use. So this query will actually answer me for tables I have in this cluster. Very small cluster is it? It is. this is all the tables in cluster. Of course, sorry, but again, you cannot see this. This is biggest table. That table has roughly more than 1 billion of rows. It is only 43 gigabytes of storage. It's also very important to stress out that Amazon Redshift gives you compression. So Amazon Redshift, on contrary to every other transactional database, those vertical database give you compression on your data. So they are using much less storage. Amazon has also a very good advisor. So basically that is machine learning system which suggests you on what rows, what tables you should apply compression, etc., etc. So that was it. Questions?
So we have 2 questions for now. How much does it cost having 1 billion of rows for 1 hour on configuration demonstrated?
For this,
Yes.
1 billion of rows. Well, this is 3-node cluster, so actually 43 gigs of storage that can be one DC, one large machine, that is $0.25 per hour. So it's very hard for any other commercial data warehousing technology. You know, so there is Vertica, there is Sybase IQ, there is probably many more of them. So it's very hard to be, you know, that cost effective as it is Amazon Redshift.
Second question, what is the advantage of specifying sort key same as distribution key versus non-specifying it at all?
Well, but that is I think, question regarding architecture of a cluster. So if you are using sort key, then your data, or distribution key, then your data will be, you know, distributed through cluster, much more powerful, how to say that.
Have you considered using Azure?
No, never.
So we're out of questions. If there are more questions from the audience, we can use the microphone now. If not, then thank you very much. Before you leave, I would like to give you the certificate on behalf of the organizers.
Thank you.